to a science lesson. Today we'll be looking at the modern periodic table and the electron configuration. These are good for the GCSE, BTEC and T-level exams, and maybe A-level. So the main objective for this is to see the way that the modern periodic table is organized and to be able to draw the electronic configuration of the first 20 elements. So let's have a look at our keywords. We have an electron shell, an electron configuration, a period, and a group. What do you think these are? Pause the video and have a go. Okay, time to talk about the definitions of these words. Now, an electron shell is an energy shell outside the nucleus that has electrons. Okay? An electronic configuration of an atom, of an element, describes how the electrons are arranged in shells. We'll talk about that later on. A period is the horizontal row, so it's the you know when you go horizontal on the periodic table, that's called a period. It goes from horizontal across the page, across the periodic table. A group, however, goes down the group. We'll talk more about the reactivity of the bonds in a future lesson. So, the lesson outline for this session is to figure out the electron configuration, which is an atom consists of a nucleus that has both protons and neutrons at the centre of the atom. So as you can see here, you have a nucleus, a proton and a neutron in the middle of the diagram there. An electron shell, we have an electron shell, which is the big circle at the side of the proton and electron and nucleus. The purpose of the electron shell containing electrons with a specific energy carries the electrons with the energy orbiting the nucleus. The electronic configuration of an atom shows how electrons are arranged in shells. Now, remember, the shell is the large circle that surrounds the atoms. Electrons occupy the lowest energy level first, meaning the shell nearest the nucleus. Now here is how they fill the shells. The first shell, the maximum number of electrons in the first shell is 2. The second one is 8. The third one is 8 because of where they're situated in the periodic table. If they're more towards the group 7 elements, they'll obviously have more shells and more electrons. They can either be drawn as either crosses or dots. For example, here we have lithium as displayed with crosses and lithium as displayed with dots. Lithium has 3 electrons. 2 of them are drawn in the first shell. 1 of them is drawn in the next shell. Meaning that one of the electrons are drawn on the very inner shell. As I said before, the first inner shell always has 2 electrons inside it. The second shell can occupy 8 electrons. There's only 1 here because there's 1 in the second shell. Then in the third shell, you're going to have 1 more. Or you don't need it. Yeah. When you go past the 20 elements, they get more and more and more progressive and more complicated, more complex. Chlorine has got 17 electrons in total. Again, and the first shell has 2. The second shell has 8. So here we have chlorine. Next we have the outer shell, the shell out of the chlorine. We need to place 2 of those electrons in the first shell because the maximum number of electrons in the first shell is always 2. Remember that. Here we have the second shell, which we are going to have 8 electrons. 8 electrons, meaning we need to put them 2 in every single corner, in every single part of the graph. Then the third one will have 7 in the outermost shell because there's 3 outer shells, as demonstrated here. We can also write this as 2, 8, 7. These numbers refer to the number of electrons that are in the outer shells. Calcium, however, has got 20 electrons in total. Again, the first shell will always have 2 electrons. The second shell will... We need to draw the 2 electrons at the beginning, at the centermost shell of the configuration. So we have 2. Then we have another outer shell, which we're going to have 8 electrons. Then we're going to have another set of 8. The third shell. Then we can have 2 more. Because you have to have 20 electrons in the outer shells for it to be a full sequence. And we can also write this as the sequence 2, 8, 8, 2. So what you need to do is you need to concentrate on the how many electrons it has and how many outer shells it's got. So for example, as you proceed down the group 1 or group 7 or any of the elements of the periodic table, you'll have more electrons at the periodic table. You'll have more electrons in the outer shells. This is because of the reactivity. And in the future video, when I'm going to be talking about reactivity with different types of acids, and when you talk about more advanced stuff like how to configure them, how to react them with more with more liquids like more reactive metals, you'll see why we need to configure them. So, here's a question. Which shell should be filled first? Is it the inner shell? Is it the middle shell? Or is it the outer shell? It's the inner shell, because we need to start off with 2 of these electrons. We've got beryllium has got 4 electrons. Okay? Select the diagrams that show the electronic configuration of beryllium correctly. I'll give you 10 seconds to answer this question. Okay. It could be either A or C. Not D, not B, because they are both circle and square, and also it needs to fill the full shell. Sulfur has 16 electrons. Select the diagram that shows the electronic configuration of sulfur correctly. I'll give you 20 seconds for this. Okay, it's B, because we've got 16 electrons and we need to spread them out across all 3 shells. And remember what I said earlier? All of the outer shells have to have been filled. You can't just leave one corner with no electron shells. With no electrons, sorry. Neon's got 10 electrons. Now draw or solve the electronic configuration of neon, then configure it. So we have neon having 2 electrons. Then we have a further 8, which somewhat equates to 10. Now, they don't need to be paired. This makes it way easier to count. They can also be displayed as like this. You could scatter them at different sides of the shell. Again, we have the formula, we have the configuration of 2 to 8. And here we have all the configurations. Silicon, chlorine, argon, and calcium. Now, the periodic table is ordered by increasing the atomic number. For example, we've got here the proton number of 1. Here, then they increase as you go through. Elements can be classed as metals or non-metals according to the position in the periodic table. These ones are non-metals. All of these to your left are all metals. We have rows called periods and columns called groups. So, all the non-metals are to the right of your screen. Most of the metals start from aluminium. You see boron or aluminium. The periodic table has called rows called periods and columns, and they're called groups. So as you could see, horizontally they're called periods, and vertically they're called groups. Group 6 is D, because you're always looking at you'll always have these numbers at the top of the table. The position of an element in the periodic table is linked to the arrangement of electrons to its atomic number. This group number tells you the number of electrons in the outermost shell. For example, everything in group 6 has got 6 electrons in the outer shell. That means all of the elements in group 6 will always have 6 shells. Will always have 6 of the electrons in the outermost shell. For example, oxygen and sulfur. They'll always have 6 in the outer shell. Everything in group 0 has a full outer shell, and I'll talk you through about what to call these. Got helium and neon, which the outer shell in group 0 is always full. The period number tells you the number of shells that have been occupied by electrons. Everything in this period 2 has got 2 shells that have electrons in it. This means you need to add something else to it. Well, boron and oxygen. Everything in period 3 has 3 shells occupied with electrons, meaning all 3 outer shells in period 3 is all occupied with electrons. The period always tells you how many shells there are. For example, sodium with 2, 8, 11 sodium. So, here's some practice questions that you can have a go at. Pause the video and find and figure it out. What period is boron in? Which elements are in group 3? Now you need to count the columns going down. Okay? On the periodic table, there are the elements are organized and increasing the atomic number. There are the vertical columns, and they are organized in decreasing atomic number. And to conclude, I'll leave you with these questions, and the next video will answer them. Thanks very much for watching.